Welcome, class, to the Intro to Java Programming. In this lesson, we will review encapsulation, one of the major building blocks to object-oriented programming, along with some rules to follow for classes, properties, constructors, methods, and access modifiers. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we will focus on encapsulation. Encapsulation simply means binding object state, known as properties, and behavior, known as methods, into a single unit and enforce modularity. If you're creating a class, you're doing encapsulation. Encapsulation also ensures that your data is hidden from external modification, also known as data hiding. Yes, this definition is a little vague until you better understand the true meaning. Let's start with an example that covers an overview of encapsulation. Let's say this puzzle piece is a class. If you're creating a class, you're doing encapsulation. Inside the class could be constructors, properties, and methods. The properties are the data fields and object state. The constructor and methods are the behavior. The contents of this class is a single unit with a single responsibility. Properties can be public or private. Constructors and methods can be public or private. Expose constructors, properties, and methods to other classes that need to know this information. Hide constructors, properties, and methods from other classes that do not need to know the inner workings. This is data hiding. Yes, let's cover a few rules and guidelines about the class, properties, constructors, and methods, which will better explain encapsulation. There are ways that encapsulation can be done well, and there's ways it can be done poorly. There is no right or wrong answer. Let's go over a few rules and guidelines that will help you avoid poorly designed classes and make them follow the preferred standard. The class. The first rule or guideline to follow is single responsibility. Coach Joe rule number 6 states, a class should do only one thing. If a class performs more than one action, this is known as a side effect and could be misleading to other developers. In an adventure game, a goblin class could hold all the data values for a goblin and have methods to perform attacks. Is this class doing two things? Maybe. Some developers will see Goblin class and think Goblin data. They may not expect to find attacking in this class. Let's say the attack action is placed into a separate attack class. Should it contain only hand weapons like bows and swords, or could it also contain magical spells? The complexity of the code may help with the decision. If your game only allows 3 spells, it might be fine in the attack class. If you plan to have many magical spells, maybe a separate class is a better option. The program will work with 1 to 3 classes. There is no right or wrong answer. However, having a class that does one thing is the preferred approach. The next rule or guideline is class name. Coach Joe rule number 3 states, use meaningful class names. Class names should use a noun to represent its responsibility. Class names should not be confusing, misleading, or contain any acronyms. A class name monster sounds general and could be misleading as it could mean any type of monster. The name goblin is more specific. The next rule or guideline is data structure versus object. Coach Joe rule number 34 states, understand the difference between an object and a data structure. Lesson 15 covered this topic in detail. Please review for more information. The purpose of a data structure is to organize data that can be passed around or managed as a single object with the use of properties and getter-setter methods. There should be few, if any, exposed methods. The purpose of an object with responsibilities is to perform some service, add behavior, or do something with the use of methods. There should be few, if any, exposed properties. Try to remember, a data structure has things, an object does things. The last rule or guideline is, limit the number of methods and lines of code. Coach Joe rule number 13 states, a class should contain a small number of methods and total lines of code. There is no limit to the number of methods allowed in a class. Each developer will have their own opinion and each situation will be different. Just know that as the number of methods gets higher, there's a likelihood the class is doing more than one thing. Same thing with the number of lines of code. As the total number of lines increase, there's a likelihood the class is doing more than one thing. If there are too many methods or lines of code, consider making another class. So, for a class, make sure the class is doing one thing, use meaningful class names, and understand the difference between an object and a data structure. Also, limit the number of methods and lines of code. The properties. The first rule or guideline is property or variable names. Coach Joe rule number 5 states, use meaningful variable names. Use pronounceable names that reveal the intention of the variable. Monster name is more meaningful than either name or MN. The name needs to be crystal clear for you and other developers today and 6 months from now. The next rule or guideline goes along with property name. Coach Joe rule number 21 states, no type or scope definitions in the property or variable name. In the past, placing str in front of a variable name like last name would give a clue to other developers that the data type is a string, or placing a G in front would mean a global or public variable. Today, the IDEs like IntelliJ and Eclipse will show the data type and the scope, so there's no need to include this clue as part of the variable name. The next rule or guideline to follow is, properties should be private. Protected and default should be limited to unique situations, and public should never be used. If there is a property that needs to be exposed to other classes, create a public getter method. If there is a property that can be changed by other classes, create a public setter method. The setter method could perform a validation check on the new value before storing it to the property. Data hiding is accomplished with private properties and no public getter method. So for a property, make sure the property has a meaningful name, does not include any type or scope definitions, and is set to private. If other classes require access to the property, then create a getter and or setter method. The constructor. The only unique rule or guideline for constructors is object creation. Coach Joe rule number 20 states, objects must be easy to create. Only pass dependencies and configuration parameters into the constructor. Look for a future lesson on dependency injection and the builder pattern for more details. Other rules and guidelines exist for constructors that will be covered in the next topic. Methods. The first rule or guideline for methods is, like with the classes and the properties, use a meaningful name. Coach Joe rule number 4 states, use a meaningful method name. A method name should use a verb to describe the action. The method name like do stuff is very vague to other developers. A name like save is helpful, and save monster data is better. The next rule or guideline is similar to a class having one responsibility. A method should only have one responsibility. Coach Joe rule number 7 states, a method should do only one thing. A method should only perform one action. If a method performs more than one action, this is known as a side effect and could be misleading to other developers. Let me explain a side effect. Imagine you call a method getDiceRoll. You would expect this method to return a random number representing a dice roll. As part of the method, it displays the value on the screen and returns the number. Although displaying the number on the screen is helpful, the method is now doing two things. It is rolling the dice to create a random number and displaying the results on the screen. Other developers may see the method name getDiceRoll and expect just a number to be returned. They may not be expecting the result to be displayed on the screen. Displaying the result is a side effect and should be in a separate method. The next rule or guideline is method accessibility. Only expose methods needed by other classes with the public access modifier. Methods that contain internal details should be hidden or set to private. The next rule or guideline is few parameters. Coach Joe rule number 14 states, methods should have few, if any, parameters. 0 is the preferred number of parameters. 3 or more is an indication of poorly designed code. Remember, the fewer the number of parameters, the better. The next rule or guideline is also about parameters. Coach Joe rule number 37 states, Boolean or null parameters should not be passed. This is an indication of poorly designed code. This rule is typically broken when rule number 7, a method should do only one thing, is also broken. The last rule or guideline is, limit the number of lines of code. Coach Joe rule number 22 states, methods should have very few lines of code. Methods should ideally have 5 or less lines of code. 15 or less is satisfactory. However, as more lines of code are added, is the method performing one action? Breaking up the method into smaller methods may be recommended. The number of lines of code will always be a hotly debated topic, and there is no specific number. Just remember, fewer lines of code are better as long as the method is doing just one thing. So for a method, make sure the method has a meaningful name, it should only perform one action and have few parameters. Pay attention to method accessibility to other classes. Do not pass Boolean or null parameters, and have very few lines of code. Sure, let's review the important aspects of encapsulation. If you're building a class, you're doing encapsulation. Make sure the class has only one responsibility. A class should be either a data structure or an object that performs a responsibility, not both. Data hiding is used to reduce accessibility by other classes. Properties should be private and could offer a public getter-setter method if needed. Expose only the methods needed by other classes and hide methods that contain the internal details. One difference between junior-level developers and senior-level developers is the ability to understand the preferred rules of encapsulation. Get in the habit of following these rules and guidelines as often as possible. You will notice design, coding, and testing becomes easier. Time for some code examples. Let's create a new project in IntelliJ. I'll be using Maven. Enter in a name, OOP Intro. Set up the artifact ID, click Finish. Let's create a new test package called Encapsulation. Let's create a new test class called Goblin Encapsulation Test. Let's make some space. Copy in this first test. Make sure these classes are imported. This first test will check two types of properties, one public and one private. A new Goblin object is instantiated here. The value from the class public string is stored in a variable called actual. The next line asserts the value matches the expected result. The last line holds the value from class private string. There is no test because we know this line will generate an error. Private properties cannot be accessed. In the second test, the public and private methods are tested. A new Goblin object is instantiated here. The value from getMonsterName is stored in a variable called actual. The next line asserts the value matches the expected result. The value from getClassPublic method is stored in a variable called actual along with the assert to verify the expected result matches. The last line holds a value from getClassPrivate method. There is no test because we know this line will generate an error. Private methods cannot be accessed. Let's build our Goblin Encapsulation class. Let's create a new Java package called Encapsulation. Let's create a new class called Goblin Encapsulation. Here are 4 properties needed for this example. There are 2 private properties used by the class and the constructor. Then there are 2 more properties used for testing, one public and another private. Remember, properties should be private unless you have a very specific need. Here is a constructor that is used to set some default values. Here are some getters and one setter. Getters and setters is how you control access to private properties. Remember, you do not need a getter and setter for every property. This is how you control access to ensure data hiding. Here are 2 methods, one that is public and another that is private. Remember, public methods expose behavior, private methods hide behavior. This final method proves all the public and private properties and methods are available for use inside the class. These are the methods. Notice there are no compiler errors. These are the properties. Again, notice there are no compiler errors. This class can access all of these properties and methods. Let's go back to the test class. In our first test, uncomment this line out. This proves that private properties are not accessible to other classes. We'll comment this line again. In the next test, there's another commented line. Let's uncomment it. This proves that private methods are not accessible to other classes. Let's comment this line again. Now we can run these tests. Let's run the first one to prove public properties are accessible. This test passes, and we'll run the second test to prove that public methods are accessible. And this test passes. Here's a summary of all the test code that we wrote for this lesson. You should now have an understanding of encapsulation along with some rules and guidelines to follow. Classes and methods should only have one responsibility. A class should either be a data structure or an object with behavior. Access modifiers will control accessibility to the class, methods, and properties. Data hiding is needed to restrict access by other classes. In the next lesson, we will discuss inheritance. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!